Let's now go into the infile.yaml file in the Hashcat directory and make some changes. Using the infile.yaml used in tutorial 1 as the starting point, we'll keep the number of agents within the simulation constant by having 1000 initial and maximum agents. For quickness, we'll lower the maximum simulated time to 1000 simulated minutes. We'll keep the maximum analysis steps to be unlimited for the most refined solution, and also keep the max real time to 1 minute, since we don't want the simulation to run for any longer than that. Interactive mode shall remain off, so both enable interactive mode and enable Lua hooks will be false, and the Lua script will be irrelevant. Use Barabasi will be used in tutorial 4, so this shall be kept false for now, and the Barabasi connections will therefore also be inconsequential. The Barabasi exponent will also remain at 1, since this gives the most realistic results. Use random time increment will be set to true for superior results. Use followback will remain false, and the follow model will remain random, with the model weights, which are only necessary for the Twitter follow model, being ignored. We set them all to 0 for this example just for clarity, but they will have no impact on this simulation either way because we are running a random, not a Twitter follow model. We're going to not allow unfollowing to occur in this network simulation, but you are encouraged to experiment with it when creating your own network simulations. We'll discuss this in a later tutorial as well, but for now we're going to set stage 1 unfollow to false, and the unfollow tweet rate will be set to an exceptionally high number for the simulation. Here we have 10,000 tweets per simulated minute. Therefore, since no agent's going to tweet that much, we don't have to worry about the unfollow tweet rate affecting our simulation. We have also kept the probability of hashtag presence in tweets to be 50%, as we can see by this being set to 0.5. Since the number of agents within this simulation will remain constant, the add rate will therefore be 0. The output section of infile.yaml will also be left as is to produce as many data files for analysis as possible for now. If you later on when you're working with Hashcat and there's some files here that you just don't use at all, you're welcome to switch these variables to false, but for now we're going to have them all set to true. The tweet and retweet ranks have remained the same, though their purpose is just to organize tweets and retweets respectively and have no real impact on the simulation. The follow ranks max threshold and weight have also remained the same, with their minimum values being 0 and 1, and their maximum values being a number greater than the number of agents, and that value increased by 1, so we have 10,000, which is more than the number of agents in this network, and 10,001. Though this will not impact this simulation, it is very important for the Twitter suggest follow model and will therefore be elaborated on in tutorial 4. The tweet observations section of this program will be kept as is for all of these tutorials actually. You're encouraged to change and experiment with it when running your own simulations, but it will be left as is in all these tutorials. For more information on this, on the tweet observations, and for everything else in the input file, please reference the input page in the documentation. Oops, sorry. The ideologies and regions sections have remained the same as well, but we have added another agent type into our input file. So we'll change that here. The preference class as well, will also be left as is. These will all be elaborated on in later tutorials. But as I mentioned, we're going to add an additional agent type into our input file. We're going to add the celebrity agent type. This celebrity agent type is of course intended to mimic a celebrity user, while the standard users we have here is used to portray a typical agent on a social network. To create the celebrity agent, we're just going to copy what we have for our standard agent type. And just paste it below. Oh, actually, let's make it a little cleaner so it has the correct indentation. There we are. In contrast to the standard agents from tutorial 1, the standard agents in this simulation will have a fallback probability set to 0 for them. And just to illustrate that they will only follow other agents through the follow model, we have done this, though we did already have use fallback set to false. Therefore, the fallback probability really is irrelevant since use fallback is set to false. We just, like I said, have done this just to illustrate this point. We are going to have the standard agents have a constant follow rate and tweet rate of 0.01. And we'll also do the same for the celebrity agent types. For the celebrity agent type, I should say. The only thing that we will change about the celebrity agent type, however, is its add weight. Where instead of 100, we're going to change this to 0. And what this means is that they essentially won't be added into our network simulation. Only our standard agents will be. Oh, very important. Need to change this name from standard to celebrity. There we are. So we can tell the difference between our two agent types. Like I said, celebrity agents won't be added into this network simulation. The obvious question is, why even create them then? The reason we created them is the celebrity agents actually won't be used until tutorial 5, where agents will follow other agents based on their agent type. We just created this agent type. We just created this agent type already, just because we want to keep all the input files that we're using for these follow model tutorials relatively the same, so you can really compare the output between them. So that's why we've created these celebrity agents for tutorial 3, even though we're not implementing them into our network. You can now proceed into the next video where we actually run this network simulation and visualize it.